Welcome back to Chemistry 1. This is Unit 4, Lesson 2, Video 1. So in this lesson, we're going to be looking at the periodic table a little bit more in depth than we have before. And we're going to be talking about the different groups of elements and tying in what we learned about valence and ions into that. So we're going to start with a history, a very, very brief history of the periodic table, and we're going to talk about Stanislaw Cannizzaro. And from the time that we started figuring out what elements were, people tried to categorize things, and this happens all the time. Humans like to put things into categories and organize them. So that's what people were trying to do, and there were all different types of periodic tables that really just didn't work well. And it wasn't until the mid-1800s that people started coming up with different ways that were pretty much on the right track. And what Cannizzaro did that added to this is he developed a system for measuring relative atomic mass, or relative masses of elements. And that's going to be used by scientists. So there was one guy, I believe his last name was Newlands, who came up with a periodic table that was very similar to music octaves. And he was on the right track because we know 8 is a pretty important element. And remember that back in this time, not all the elements were known that we know now. So when they tried to put the elements that were known, scientists were like, oh, that's it. There are no more elements. And it just didn't fit into some kind of pattern. And it's going to be 1869 when Dmitry Mendeleev, who is a Russian scientist, he is going to be working on how to organize these things. And there's a myth that he had a dream with playing cards and all of this stuff, and he came up with this idea. He jotted things down as he woke up at night on the back of an envelope, and he came up with the idea for how to organize the elements. And actually, it was pretty ingenious. So he is going to develop the first modern periodic table. And he's the one that's given credit for most of this. And there's even an element named after him, Mendelevium. And what he does is he arranges the elements based on increasing mass. Excuse me. And the one thing that he does that is different from everybody else, he saw a pattern, but there were gaps. And he left spaces in the periodic table for elements that were not yet discovered. So he left spaces where there were gaps in the table, and he predicted undiscovered elements and he even predicted the properties of these undiscovered elements. For example, underneath aluminum, he proposed the element aluminum, which means below aluminum. He gave it that name because it's below aluminum. And he predicted things like what melting point, how reactive it would be, all different things about it. And then when this element was discovered and it was named gallium, it fit. So it wasn't until then, many years afterwards, that he is given credit for his periodic table. So when these elements were discovered, they matched his predictions and the table was discovered. And I put quotes around that because really the periodic table is just a tool used to help with information. So it's a man-made construct. So the periodic table, we have one. We have one that works, except there are a couple things that didn't work well. There are a couple little tiny wee problems within it that things didn't quite fit. Some of the elements were switched around a little bit because they were based on mass. And if you remember back when we talked about mass on the periodic table, we said that mass was based on isotopes, and we had different versions, but they didn't know that at this time. So we have to wait until 1911 when we end up with somebody named Henry Moseley. And we have to wait until 1911 because after 1911 we knew about protons. And protons were determined to be what is going to be the order of the periodic table. So we know already that the atomic number, that's how the periodic table is based. So he rearranges the periodic table based on increasing atomic number. So remember, that is protons. And this is what we still use today, is Moseley's rearrangement of the periodic table. But the periodic table is a living document. So as new information is learned, it gets changed. Remember that science does change based on new information.